Hello guys and girls, that's me, Gleb Alexandrov. Welcome to the bonus tutorial from Creating Stylized 3D art series by Mano Järvinen, Eevee Burrows and me. Here is a plan for this video. We will take this low-poly isometric diorama that we have created in the second part of the course, and we will explore a bunch of pretty cool stylization options. It won't be a step-by-step explanation, but rather a gateway drug into the world of NPR techniques, and also, I hope, a gateway drug into our course as well. So if at any point you would like to dig deeper and to support us at the same time, don't hesitate to follow the link in the description and learn more about creating stylized 3D art in Blender. The first style is gonna be the one that we have actually chosen for the second part of the course. I would call it the Eevee Lowpoly look with a semi-realistic rendering. Actually, it's pretty interesting because rendering-wise it's no different from the realistic look. It still has lights. These lights behave in a physically plausible way, even though it's Eevee and not cycles. The camera and geometry, on the other hand, are worth talking about. The camera is orthographic. It means it has no perspective. So that is already shifting this look to the stylized realm, so to speak. And then we have the moody stuff like the principled volume shader for the fog, which also can be seen in the realistic contexts as well. It isn't something that is inherently decorative or realistic. And the bells and whistles like ambient occlusion, bloom, motion blur and so on aren't as well. The key feature of this look, as I see it, is a nice balance between the more realistic rendering and the highly exaggerated and simplified geometry, and the perspective is simplified as well. So this style is all about juxtaposing the simplistic low-poly elements and the semi-realistic rendering. The second type of the look that personally I would experiment with is the Toon shading look created by the shader to RGB node in the shader editor mainly. Just like the previous look, it does use light sources to generate the basic lighting, so it isn't shadeless, but then the lighting information is passed through the shader to RGB node. So once again, it works like this. Principled BSDF goes into shader to RGB, that goes into the color ramp, where all magic happens. In the color ramp, we define the colorization of the shader to RGB data. And by utilizing this simple setup, we get a complete artistic control over the gradations of light and shadow and the colorization of this process. We can even control and fine-tune such properties as interpolation between these stops on the color ramp, which may be quite important for your style. Or not, but it's good to have. So here is the setup for this kind of look, nothing too complex, the rest is just choosing the color palette. And then there is pixel art, of course, a nostalgic and so fascinating style that we can experiment with in Blender. Alongside the pixelization, it also often involves posterization effect within the compositor. We can do the posterization effect with the help of the separating hue saturation value, and then recombining these three parameters, but we do something with value along the way, namely we multiply, round and divide it by a certain number. And this number controls the intensity of the posterization effect. So all of these jazz is meant for reducing the bit depth of the image, something like that. And then we do the pixelization part. It's pretty straightforward. We scale down, pixelate and scale up the image. That's it, nothing too complex. Just scale down, pixelate to bake the pixelization, then scale up again, and you get the pixelized version of the image. So that's pretty much it. These two operations that we do within the Blender compositor allow us to create this pixel art effect. And lastly, we can control the sharpness of the effect, if I can put it like this, with the help of the blur node that we use to pre-blur our stuff. Then I couldn't help but mention the retro color quantization shader by Alex Heskett. You can find this shader on Gumroad. It's free to pay, so you can name your price or download it for free. Basically, that's the NPR technique that is also based on the limitations of the hardware of the past. It uses color quantization or posterization and some dithering, just like the pixel art technique that we have described before, but the shader itself is much more elaborate. And what I absolutely love about this type of shader and about this look in general is that it supports the limited color palettes that you can generate yourself and then simply plug and watch the colors changing. I definitely have a soft spot myself for these kind of nostalgic looks. I think they are very cool indeed. When I try to replicate one of these looks, I instantly think about the hardware that may have displayed it. That is such a fun stuff. And then we have this comic book look, which is inspired by the Spiderverse chromatic aberration, style, depth of field, and other effects of the printed medium. In the compositor, it starts with generating the freestyle outlines and mixing it with the original image. Then comes the chromatic splitting effect, which is based on the depth of the scene, on the Z depth or the mist pass. The mist pass is needed to control the focal point, to simulate the depth of field in other words. And then we plug the resulting color ramp into the displace node, the red and green channels, to shift them to the left and to the right respectively. But the coolest part is that we can focus it using the color ramp. And we get this pretty neat chromatic aberration style depth of field as seen in the Spider-Man Into the Spider-Verse movie. And on top of it we can overlay the halftone pattern, the cross-hatching pattern, maybe the posterization effect and other stuff that is characteristic for the printing media. Or we can make it monochromatic if you wish, like a sketchbook or something. Next we can get this Lord of the Rings swirly abstract effect by utilizing Denoiser in cycles in conjunction with generating lots and lots of noise. Generating lots of noise is easy, you can use the volume shader for example. So here we go, noise! Bravo! And then we can enable the viewport denoising for example, and it will already look swirly. Alternatively, we can resort to the interlopen image denoising node within compositor that is called simply denoise. And combined with a low number of samples, and with a higher amount of noise, it will generate the bombastic abstract effect we're aiming for. Oh, and don't forget to click on this clock icon to enable the random noise seed for each frame of cycles rendering. The Voxel Art type of look is a big one in the NPR world, and even though Blender is no contender for Magica Voxel in this sense, we can still replicate this look to a certain extent in Blender, and we can do it pretty easily actually. Within the modifiers we have the Remesh modifier, and within this modifier we have the Blocks mode. So by activating this mode and unchecking the Remove Disconnected checkbox, we tell this modifier to blockify, voxelize everything. So that's a step towards the voxelized artland. The projected paint look, which is definitely one of my favorite. Kudos to Lena for overpainting this render. So this style is super duper NPR, almost to the extreme. First we prepare a layered Krita overpaint file. Then we export it to a bunch of PNG files with transparency. The one for the trees, the other one for the sign, and so on. So we should create a bunch of images, each for its own layer of geometry, and use them as textures that go into the emission input of the material. So now all of our materials are effectively shadeless. And then we unwrap all the objects with using the method called project from view. We need to do it in the object mode after selecting all the polygons. Just press U and then select project from view, otherwise it won't align with the art that you have painted on top of your render. And this is it, a gorgeous painterly style, very easily. You should definitely try it out. Well, the tricky part is to paint the actual thing, but anyway.
Gleb has already mentioned a simple way to get a Toon shader out of Blender. We use the shader to RGB node in Eevee, and only Eevee, not available for cycles I'm afraid. But anyway, this is a great trick for some basic lighting. However, it does not respond to the colours of the lamps that you might have in your scene, only the overall brightness. One way to get around this limitation is to split the hue, saturation and value channels and then introduce the map range node in between for the value and the separation, leaving the hue alone. Once we change the mapped range node from the default linear to stepped linear, we can then change how many degrees of banding we want. This is basically the same as the posterization technique, by the way, but just in one handy node. A super simple hatch-in that we can also get out of this method is by simply adding a wave texture to the bump node. We can control this easily enough with just our UVs, so we can choose our hatching line sizes and direction. We can also change some of the settings on the nodes to refine the desired look too. One other interesting addition to this are the outlines. When we limit the amount of color and value information, that means often a lot of details are going to get lost. That's why in a lot of flat cell shaded art, we'll see the artist gives them outlines for that extra readability. One cool way to do this is a technique that dates back to early video games, going for this same kind of effect. And that's to simply invert the geometry, expand it or shrink it slightly, to give these shells a little bit of distance between each other. Luckily, this is easy for us to do in just one solidify modifier. We just need to ensure that we flip the normals, set the thickness of the outline, and specify that we want to use another material for this. 0 being the first slot, 1 being the second, and so on. The material is easy to set up, just a black emissive will do, or maybe a white emissive, whatever helps those details to pop. So we got pretty close to white in this case. But just remember to colour our back faces and to not cast shadows, otherwise we may not be able to see through into the glorious modelling that we've done inside this cocoon of polygons. Another nostalgic technique looking to save on printing ink is this halftone look. These dots are really easy to make. It's just a Voronoi texture that doesn't have any randomness on it, so let's just set that to 0. And then this subtract node just is doing the inverting for us, turning the dots from black to white. Or actually we could invert it on our map range node instead, actually, if we like, by flipping the min and max values. Here I'm just bringing the values together to compress the range a bit, which means I'm kind of clamping just how large or small the dots can get before they just flip straight to black or white, which is what our less than node is doing. That's the real hero of the halftone show here. No grayscale allowed out of this node, only black and white, which we can use to drive the factor between the two end colors that we really want. We can alter the threshold of our less than node to change the size of the dots really easily. That means we can now plug in whatever we want into that, be it a texture or actually take the shader to RGB node for another spin. Then we can control that with a color ramp or a map range node to adjust to taste. A couple of variations to keep in mind here for our dots are that we can either choose to use the UV coordinates to align more to the object itself, or we could instead use the window as our coordinate system, meaning we get all the dots aligned directly to our view and not affected by any perspective of the geometry on our object.
Yet another popular style is line art. And in Blender, one of the ways of creating non-real-time outlines is Freestyle module. It could look pretty convincing when used on its own without the underlying render. If you want to play with Freestyle, you should activate the Freestyle checkbox first within the render settings, and then in the view layers enable the As Render Pass checkbox in order to use it in Compositor as a separate layer. And the rest is tinkering around with the numerous properties of Freestyle. There are a lot of settings within Freestyle to explore, especially if you're gonna combine a few line sets to create even more elaborate line art. That can get out of hand really quickly. There are a lot of things worth exploring, for example modifiers. You can add modifiers to affect thickness, geometry, color, and other parameters of the lines. For example, in geometry modifiers you can try enabling polygonization, backbone stretcher, and other cool stuff. And after rendering, when you remove the original RGB image, it will result in something like that. So that's for the non-real-time line art. And here's yet another one, the neural network-based style transfer and some EbSynth. Before actually using EbSynth for the style transfer, we can generate the checker style texture in Blender, then take our original animation and blend in the checker texture on top of it. So it looks something like that. Pretty strange, but it'll work just fine. Then we can render a few normal frames from our animation, the so-called keyframes, and transfer a certain style onto them using Deep Dream Generator, or maybe any other style transfer software for that matter. Deep Dream Generator can be used for free with certain constraints. So here we go. We should get something like that. And we can use this frame or a couple of frames in EbSynth to transfer this style onto the entire animation. We define the source video with the checker effect, then our stylized keyframes, then hit synth and enjoy the result.
Another option available to us to create stylized art within Blender is to use the MALT render engine. This is part of the ongoing Beer project. The project is currently looking for extra funding to fast track this into completion. And the very cool thing is that it's actually available to try out right now, and we can download it here. We're currently sponsoring this, as you can see, to help push things along a little bit. I'm on a Windows system, so all I would need to do is download the zip file, which includes the MALT renderer as an add-on. And so that we've got something to play with, we can download the shader examples too. In addition to this, we're going to need to download Blender, of course, but I wouldn't recommend downloading the main Blender. I would go to this page here and take in my case, the Windows portable zip file. That means we're left with these 3 files. The next thing to do there would be to unzip these, the shader examples and Blender itself. Once Blender's unzipped, just click into it, click into the 2.92 area, or at least for me it's 2.92. That's the latest official Blender release as I record this. The only thing you kind of need to do out of the ordinary is to create in here a new folder. I'm going to need to call this config. From there, all we need to do is to find the blender.executable that we've just unzipped, and we can run it from there. I'm just going to keep all the defaults, and I'm going to launch our preferences, and I'm going to come over to the add-ons, come to install, find where we placed our Blender MALT add-on, and then just install the add-on. It might take a little bit longer than the average add-on to install, so just bear with it. And now we have the MALT render engine available as an option. By clicking on the checkbox, we should be able to come over to our render engine settings, and now we'll see MALT there as an option. So let's switch it over. Now let's come down to the material settings, and we'll notice a few things look a little bit different. First of all, I'm going to press Z to switch into rendered mode, and let's pull this out a little bit more. We'll see that things kind of go a bit yellow, and that's because we don't have a proper shader on this. And this is why we unzipped our shaders before. What we need to do is open that up and then navigate to where we unzipped our shader examples. A simple one would be, say, this basic mesh. Double click on that, and now we're starting to get somewhere. Let's click on our lamp here and just move it a bit closer. Or maybe even better yet, let's switch to a sun type of lamp where distance to the object isn't going to affect how bright it is there. We have color for our lamp here as well. I'm just going to leave that on white. Jump back over to the material settings of our object here, and we have some basic settings that we can tweak to change our stylized look. Note that this selecting a shader from our shader folder is all a work in progress, and this is all under development to make it all as frictionless as possible for the artist. The user interface and the experience, the underlying code, remember, all of it is being improved. But it's cool that we can play with this even today. Here I've just gone Control-C from another blend file and Control-V'd it into this one, just to indicate a couple more things. The color management all still works, but for a lot of stylized stuff, maybe we might want to switch it to standard. Taking a look at the lamps, not all the lamps are currently supported, I don't think, so area isn't going to work for us. But otherwise we can get some pretty nice shading almost right out of the gate. So let's take this into the blues, and this one I might take into being a little bit more this kind of shade. I found even with the basic mesh, we can actually just set the roughness quite high, like 3, and then I'm going to Control-C and Control-V the specular color, and we get a harsh kind of Toon shading right off the bat there. But we can also just simply set 1, choose the gradient mesh option, set this to constant, and now we have the typical Toon shading kind of fall off we might be more used to. In fact, we can separate the specular. Let's switch that to constant as well and bring that down a little bit. And what I think is extra cool about this is that we can set our colors here, or control click in here and create yet more varieties in the gradient, but it's also responding to the color of our lamp. So if we want to make this a more intense color, it'll follow along. Something that isn't as easy to do in the native renderers. Something else we could try here is switch over to the basic line mesh, and I'll turn up the roughness quite high again, and take a look at the fact that we've got this line width. And if we take this up a little bit higher, we can see we're getting a really nice outline there. And I think being able to manipulate the line here like this, and I think there's an even advanced version, advanced line.mesh, that we could try out. And the amount of controls that we have completely outdoes a lot of the options that we would have in native Blender. So well worth taking a look.
Alright, that's it. I hope you enjoyed this quick journey into the world of NPR techniques. I would also like to express our gratitude to the folks from Blender NPR. The NPR stuff that they share on their YouTube and Twitter is invaluable. It helped us a lot. It taught us a lot about NPR, and I hope that the course for Blender that we have just released could be a nice contribution to this space of NPR art. That was Gleb Alexandrov for CreativeShrimp.com. Feel free to follow the link in the description if you want to learn more about all that stuff and if you want to support us as well. Drink more coffee and we will change the world of computer graphics.